Hello friends, let us talk about a dynamic subject, thermodynamics. By naming, this is thermodynamics. Thermo means temperature, dynamics means motion. In this subject, in this point, we will study temperature in motion, means temperature in flow. The branch which deals with movement of energy. We know if there is a energy, it can convert from one form to another. That will be deals that we will study in this thermodynamics. One form to another form, and a relation between heat and temperature, and it will establish the relation what is heat and what is temperature. Heat means due to gaining of energy of electrons and protons. And temperature, when heat flow from colder body to hotter body, from hotter body to colder body, that is temperature. And with energy and work done, and if there will be energy, then it heat energy, it can transfer to mechanical work. So this is totally we will tell it is a thermodynamic. How it is produced, how it is utilized to do mechanical work. Then we will come to know some terminology: surrounding system and system boundary. System means this is a system. We are keeping some hot water here. Then imagine this is a container. So the heat will be passed through the wall, and the water vapor will go outside the, this is open container, then it will go outside. So this is the system. The hot water is a system, and the container wall is a boundary, and the which present outside the system, that is surrounding. This is the surrounding. Means the system will radiate energy will be transferred, and it will radiate some matter also, it will go to the surrounding. So overall we know this is a system which we are studying something else, that is system, and the wall of the container is boundary, and the outside is surrounding. Then there are three types of system, mainly isolated system, closed system, open system. ओपन सिस्टम ये क्या है, ये दोनों एक्सचेंज करता है. ये क्या सिस्टम में है, ये एक्सचेंज एनर्जी, एक्सचेंज मैटर मतलब ये पकड़िए, ये पानी रखा हुआ है, वो बॉयल हो रहा है. ये क्या होगा, पानी भी ऊपर जाएगा मतलब एनवायरनमेंट को पानी भी चला जाएगा, एनवायरनमेंट को एनर्जी भी चला जाएगा। इसका हीट एनर्जी जब एनवायरनमेंट चला ये ठंडा हो जाएगा। तो ओपन सिस्टम एक्सचेंज बोथ एनर्जी एंड मैटर टू दी सराउंडिंग। और क्लोज सिस्टम, ये क्लोज है, बाय नेम इसे क्लोज है। ये क्या करेगा, ये मैटर एक्सचेंज नहीं कर पाएगा। ये कैन नॉट एक्सचेंज मैटर टू द सराउंडिंग, ओनली इट कैन एक्सचेंज एनर्जी टू द सराउंडिंग। हाँ, ये बेस्ट एग्जाम्पल ऑफ ओपन सिस्टम that we are taking a cup of tea, then the tea will colder, then the heat will be go outside, go to the environment, and it is both, and water vapor will go outside. No means water vapor means it is also matter exchange to the environment. So it is the best example of a open system. In a closed system, then इसका ढक्कन लगा दीजिए। उसका ढक्कन, ये बॉटल है, उसका ढक्कन लगा हुआ है, ये क्लोज सिस्टम है। ये क्या है, वाटर वेपर बनेगा तो फिर वाटर वेपर ठंडा होकर फिर वही कंटेनर में गिरेगा। तो ये क्या है, ये मैटर एक्सचेंज कर नहीं पाएगा बाहर, एनवायरनमेंट को नहीं दे पाया, और क्या करेगा, ये एनर्जी वही दे देगा। थ्रू बाउंड्री वॉल्स एनर्जी विल बी लूज, देन द टेम्परेचर ऑफ द कंटेनर विल बी डिक्रीज। सो इट इज ए बेस्ट एग्जाम्पल ऑफ अ क्लोज सिस्टम। एक गर्म पानी रखिए, उसी में ढक्कन लगा दीजिए बोतल में, क्या होगा, वो पानी ठंडा हो जाएगा भाई। ये क्या, एनर्जी, जो हीट एनर्जी विल गो आउट, एंड द टोटल वाटर विल बी constant, means it does not exchange matter to the surrounding. And come to the third point, isolated system. Isolated system, ये neither exchange energy nor exchange matter, मतलब it is isolation is done here. No matter go outside, no heat energy go outside, energy will go outside. The best example is thermophax. Also thermophax is partially isolated system. आप रखिए, वो 10 घंटा तक ठंडा नहीं होता है, मतलब एनर्जी में एक्सचेंज नहीं होता है। और जितना आपको कप रख कि जितना हॉट वाटर रखिए उतना हॉट वाटर रहेगा आपका। ये बेस्ट एग्जांपल ऑफ आइसोलेटेड सिस्टम। थर्मोडायनामिक इक्विलिब्रियम। थर्मोडायनामिक इक्विलिब्रियम क्या होता है भाई, a state of physical system in which system in mechanically, chemically and thermal equilibrium, in which there is no tendency of spontaneous changes. जब ये फिजिकल सिस्टम ये mechanical means it has no tendency to do work, means mechanically isolated. It has no tendency to do mechanical work. Chemically tendency, it has no tendency of reaction. Any reaction will carry it out. So it is chemically stable. And thermal equilibrium means it is no contact with the colder bodies. There is no flow of heating. So it is known as thermodynamic equilibrium. Thermodynamic equilibrium. And extensive property of, then properties of heat. Two type है, one है extensive property, one है second है intensive property. Extensive property extensive property refers to a thermodynamic property of system whose magnitude depends upon mass of system. For example, property include mass, volume, internal energy, enthalpy, entropy. ये totally depend the system magnitude of mass of the system. कितना मास है, मास ज़्यादा होगा तो ये प्रॉपर्टी ज़्यादा होगा, मास कम होगा ये प्रॉपर्टी कम होगा. Intensive property, thermodynamic property that does not depend upon the mass of the system. Example, intensive property include pressure, temperature, density, specific volume, specific internal energy, specific enthalpy, specific entropy. These are intensive property. They are not dependent on the mass of the system. ये मास ज़्यादा कम से कोई मतलब नहीं है. Then internal energy. Internal energy plays a vital role in thermodynamics. We know what is internal energy of a system. The total thermal energy of system, the average kinetic energy of the system's constant particle due to their motion. The total internal energy of system is the sum of kinetic energy and the potential energy of its constituent particles. Internal energy, what is internal energy? It is the sum total of kinetic energy and potential energy. Where is it? How it is developed? We know that structure of atom. There is the proton, neutron and electrons are evolving by making energy cells. And this will be increased somewhat by gaining from external energy. So, the internal energy of the system is totally depends upon its particles, constituent particles, state of constitutional particles.